All right, everybody. So my name is Sonny Mounicou, and I'm here at SkyDogCon to talk about building a UAV. Probably a little over a year ago, I started down the process of building my first quadcopter, and then it sort of spiraled from there. And I thought that it would be interesting, just given the nature of UAVs and government use and everything else. I thought it'd be interesting for folks to learn about what we could do with a UAV and just some of the lessons learned that I had, some things that some options that you have available to you, what's really considered a UAV, et cetera, et cetera. So what I'm going to do is I'm going to speak for quite a bit. You'll have to forgive me. I've got a cold, so my voice may cut in and out. But I've got a few examples here, and what I'll do is I'll probably spend the first half an hour going through my presentation, maybe a little more if I'm slow. And then I've got some that you can walk up and see and get a feel for what they really are. And I'll talk about those capabilities. All right. So first, I wanted to introduce the different models that I have up here so that you have a perspective as we go through the different slides, what we're going to do. You'll have to forgive the dog and the baby's toys in the background. This is where I do a lot of prototyping in front of the couch. But this is the quad that you see there. If anyone saw my presentation last year, I actually had a number of pictures from this one where I had gone through a number of iterations of the frame. This is either the fourth or the fifth iteration of the frame, and I'll speak a little bit more about it at the end. But you can see here that I've got a 3D printed case on the top. The aluminum arms are obviously purchased, but the mount that holds them in is milled on a CNC machine, and then the actual motor mounts have been 3D printed as well. Like I mentioned, this is the fifth iteration, and this uses the ArduPilot software. So it's probably the most capable of the three at this point, but it's also the most difficult to tune and to use accurately. This one right here is a F450 frame by a company named DJI. You actually see the most attachments on this one because this is the one that I fly most frequently now. I found that I started down the process saying, well, I'm just going to build a UAV, and I've never had an RC device before in my life. And as I learned with that one, I found I didn't know how it was supposed to fly. So I went ahead, I put it together, and I was able to fly it. But having not had a purchased one or any kind of training or anything, I didn't know what to expect from the motors or the ESCs or even the software. So I decided I would take a detour from working on the ArduPilot to build this one. And this one uses a commercial controller called a NATSA. And the frame is actually done by DJI. And I'll speak a little bit more about it. But there are a lot of features on here, and I'll talk to them as I get to the different elements of the presentation. And then the third right there, and I'll hold it up. This one's plain, obviously, compared to the others. It may be considered more of a glider because you actually launch it by throwing it. This one I decided I wanted to get into because the battery life is so short on quadcopters. So on the quadcopters, the positional control is fantastic. In other words, I can pin it in the sky and it doesn't move. But the battery life ranges from usually typically around 10 minutes, and that's very limiting depending on what you want to do. On a plane like this, I can cover a lot of ground, and I can do so for about 25 minutes. So you can imagine it's a lot more capable. Some of the advantages of this particular one that's made out of styrofoam, you can use super glue to put styrofoam back together, so it works pretty well when you crash it. And the frame itself is cheap, so if you do destroy it, an entire frame similar to this, assuming you can reuse the components, is only about $50. So it's you can really learn with it. All right, so you can see the video in the background going. With a multicopter, there are different modes that you can actually use, and depending on what your definition of a quadcopter is, a UAV is, you'll understand as we talk about those different modes. Now, the first one is manual, which means it's basically going to fly. It's going to control the yaw and the pitch, and it's going to change the motors or change the the voltage to the motors so that you can appropriately fly it. So it's going to respond like a normal helicopter, and that means that it's got to articulate the 4 blades the appropriate way. Both of these quadcopters are in an X configuration, but they can also be in a plus configuration, which means they're straight forward and back. That's a little easier to deal with, but I think the X format looks a little cooler, which is why both of these are in X format. Stabilize is kind of, I would say, like a mind-numbing mode. Stabilize makes it almost like it's a glider, so you can hold it in the air, you can push it, and it'll keep track of where it is, not via GPS, but it won't just keep going off to the side and crash. It has a little bit of I would say knowledge built into it, so it's a little more careful. When you push it, it's going to capture itself and come back to where it should. So it's a lot of, like the ArduPilot software calls that easy mode, so it's a little simpler than the other methods. Return to launch is a nice feature for a couple of things. This would be the first bit of what I would call UAV functionality. The other ones are nice. They just they're manual or sort of augmented reality. But the third return to launch is I take off from a given location and I want it to return to that location. So maybe I'm done with flying or whatever. I push a button and then the quadcopter will actually return to where I took off and actually land itself. It does that. Different software does it different ways, but effectively it comes back to where it launched using GPS and lands. This is a really great feature for a few things. With some of the software, when it monitors the battery power, it will actually say, okay, well, you know what? You have less than a minute of flight time remaining. I'm going to come back and I'm going to land, because if I don't fly back and land, we're going to fall out of the sky and crash. So it's a really great feature, and it's the first of those UAV features. That would be sort of one waypoint mode, where it knows where it came from, but it doesn't know anything else. The fourth one is an interesting one. It's called loiter. So loiter effectively hovers in a given position, and it's an interesting. If I wanted to film something or I just wanted to look over something, I could put it in loiter mode, and it would effectively hover there, dead in the sky. It would keep track of its height, and it would keep track of its positional awareness. Now, with the ArduPilot software, With the ArduPilot software, there's a lot of tuning required to make it hover in a very small circle. So you see in this video, and I don't know if it's going to let me play this video again easily, sorry. In this video, you could see it, but you could see it was about 10-foot circles. So more or less, within about 10 feet, it's going to be in its position, but it's not going to be much more accurate than that. Now, for a lot of things, that's fine. But if you're trying to film something, that's not very good. Now, it can be tuned to be within 3 to 4 feet, and it depends on the features you have in the device, whether you're using GPS, or I should say the type of GPS, whether it's a SURF chipset or it's using MTK. There are a lot of different options, but the the not-so one here, the loiter mode in it is much better. Out of the box, it loiters within about 1 to 2 feet, so I can literally put it up in the sky, and it will stay in that spot without moving. And 1 to 2 feet is not noticeable when you're far enough away. And then the last one on this list is called auto, and auto is what I would traditionally think of as UAV mode. So auto is I can program a set of waypoints in, and I want it to fly this given route. Now, we don't have bombs or missiles or anything interesting attached to this, so why you would want to fly it in a given route is a different story, but you can fly it in a given route, and that's through a number of waypoints. Now, there are commercial software that lets you do it that's very expensive, and then there's the open source ArduPilot stuff which allows you to do it, and it's not nearly as pricey, and it's very capable of doing waypoints. It's probably a little more tuned to planes and waypoints, but it works for quads as well. And I wanted to start here because I think it's important to know that as you talk about UAVs, it goes from anywhere from just making it easier to fly all the way down to full waypoint analysis. Now, what I don't have in here, what I don't have in this list, are some of the items that the NHTSA has, because it's a commercial piece, and I don't know that I would necessarily consider it UAV functionality, but it's something that makes it easier. So there is a feature they call intelligent orientation control. So if I were to think about wanting to film myself, and I were at the very center of a circle, there's a feature in the NOTSA that allows me, it puts the NOTSA effectively in I guess, radial coordinates. And so, oh no, sorry, polar. So what it does is it will allow the UAV to go around me in a circle while always pointing the camera directly at me. And I don't have to do it with me as the center. I could do it with my wife at the center or anybody else. But if I wanted to film someone in a 360-degree view, I could do it very easily, and it would be kind of neat to work it that way. You can also do that with rectangular coordinates, but that's what they call intelligent orientation control. And when I flip the slides, you'll see for the first second the video playing when I have videos. That's where you can see the most detail on it. All right, so this is where I go into a lot of detail on different builds. The reason I put this picture on here was this is the DJI frame, the F450, and you can see it's crashed. In this particular one, I made the user error of mounting actually setting the configuration parameters for the GPS incorrectly. So it thought the GPS was under the quadcopter. And what it did was I was flying it at a park, and it took off, and then it went about 35 miles an hour and then smacked straight into the ground. And you can see I broke 2 of the arms, and I actually ripped the wires out of one of the motors. This can be expensive, depending on what you break. But one of the nice things about the one that you buy, like the F450, is each of the frame arms is only about $8. So at the end of the day, I've got a whole box of those that I can just throw back on the quadcopter if I crash it, flying it how I shouldn't. Whereas on my custom one, I'm going to my garage and I'm trying to mill something or actually create it, which is much more expensive and timely. All right, so different frame types, things to be aware of. So there are some commercial frames, and if you're just starting out with building a quadcopter or a UAV, I'd probably recommend just start out with a commercial frame. There are a dizzying number of options as you build your own that I ran into when I built mine. And once you know more about what ESC to choose and which motors to choose and everything else, it's easier. But you know when you buy one that it's got everything already figured out for you, and it makes it a little easier, and it's really not that much more expensive. So some of the common ones from DJI, they have a 330 millimeter version, a 450, a 500, and they have an 800. And each of those designates the width, how wide it is. And you can see that the F450 is obviously 450 millimeters wide. This one is closer to, I want to say 580, the one that I built myself. It makes a difference when you're doing acrobatics. So the wider the wingspan, it's going to be a little more stable, but it's going to be a lot more difficult to do things very quick or move acrobatically, whereas the 450 is very, very fast and responsive. And the 330 would be even more so, but that also means that the 550 is the easiest to control, and the 330 is the hardest because it's going to shift back and forth very quickly. The S800 is one that I included. It's got a picture at the bottom. That's called their, DJI has one called the Spreading Wings. It's ridiculously expensive, but it's a very pretty frame and a good one if you were planning to go that route and had the cash. Gowie also makes some similar ones. They have a 330 and a 500. They get pretty good reviews. Or you can go with a custom frame. My first frame actually used printed parts in the middle with aluminum arms, and I used a Tupperware container to hold the electronics, and it worked. It didn't survive crashes too well, and I can tell you I crashed a lot. In fact, I have videos of my son sitting there saying that it's flying wacky and all sorts of other fun videos. But after I cracked that frame, I did another revision, and eventually got here. So you can make them on your own. Some people make them out of wood. Other people make them out of, the aluminum arms, I bought at Home Depot. So you can do lots of stuff. It just depends on how much you want to spend and how much time you want to invest in building it. Now, you can see at the bottom, you can see the gimbal moving, the stabilization on the gimbal. Effectively, what that does is it uses the gyroscope built into the quadcopter to compensate for it turning and moving. You want to do that because it helps keep the video or the pictures very stable. You don't, when you're flying sideways and you take a picture or you're taking video, you don't want the camera to look like it's at a 30-degree angle. You want it to be steady while the quadcopter is panning to the side, if you will. And so this, you can see at the bottom, obviously you can see in the picture there, but this has the gimbal at the bottom, and you can see the 2 servos that really actuate it to hold it steady. I think that's one of the neatest things to have because it really helps stabilize the video. And if you're going to do that with the quad, it makes sense. But some of the things to think about from a payload management excuse me, perspective, how much weight can you realistically carry? Well, most of my quadcopters typically have about a pound of extra weight that they can carry. For the F450, about, I would say 75% or 80% of that pound is taken up by the gimbal mount on the bottom and the GoPro. So it almost completely consumes any excess capacity that you can have. On the quadcopter I built myself, it's taken up by the main components. And when I add the F450 on, I would say the custom quad is about 4.1 pounds fully loaded, and I would say that the knots of the F450 one is right around maybe a little over 3 pounds. And that factors into your battery life pretty significantly. But it's important to realize what you want to carry. So, for instance, one thing that would be interesting to carry on the SkySurfer would be like a Wi-Fi logger or a Wi-Fi sniffer, right? Fly it over your neighborhood, capture all the open access points that there are around, and you could do that because those devices are fairly light. But you're not going to, you're not going to carry very heavy weight. You're not going to carry a small dog with one of these. I mean, it's not, not that you want to, but, you're not going to do it. So you've got to keep that in mind, what you can actually do with it. You're looking at about a pound, or it really starts impacting battery life. And then if you look at, that ties back to what you want to do with the UAV. On the third item here, do you want it to carry a camera? Does it need to be stabilized? If you look at some of the folks online, they'll just mount a CCD camera on it, and they'll allow it to, they'll fly it acrobatically, and it's really fun to watch. But if you want to do anything with the video, it's very difficult to do anything. I wanted to be able to put it up in the sky and have it take video of something, and that it can do. And to do that, you really need the gimbal. But if you just want to get good video from it flying, then a CCD is, a couple of ounces, and it can go right on, and it's easy to do. So a couple of things. On the custom quad, I use a 3S battery, and on the F450, I use a 4S. Basically, that's the number of cells that you have for battery use. Down at the bottom, you'll see the kind of dizzying number of options that you can tweak. And the graph right there is really shows the power band of the motors. And the reason I included all that is because everything on that screen, every variable that you see listed there affects your battery life. So if you look at the custom quad, it gets about, I would say, 10 to 12 minutes of flight time. If you look at the F450, it gets closer to 4. But I can run circles around the custom quad with the F450 because it's got a 4S instead of a 3S battery. But it's, everything you tweak will make a huge difference in your battery life. But if you're building a quad or UAV, it's important to think about how long you can actually fly it. With a 7 or 8 minute life, the F450 can go 40 miles an hour. I've had it up to 38 with no problem. So for 7 minutes, you could fly it at 38 miles an hour, which means you'll cover quite a bit of ground. But you're not going to cover nearly as much as you will with a plane. So if you want to survey your farm or a neighborhood, you're not going to do it with a quad, but you could do it with a plane. But it's important to keep that in mind because it drains a lot of power. Oh, sorry. And one other thing on this one to think about is the voltage for accessories. So a 4S battery, a 3S battery is right around 12 volts. And a 4S battery is right around 14.8 volts. So when 11.1 is almost fully drained. So what happens is on a 3S battery, you can typically run most 12-volt accessories on it. It's very easy to do it, and you typically don't need to do much as far as regulating the power because most accessories are tolerant. So if you want to run anything that can be powered off a 12-volt, it's a hell of a lot easier to do that on the 3S. If you do a 4S, you're going to have to step down the voltage or add a secondary battery in order to make it work. And that can be more of a pain. So as far as the brains, I mentioned the two different ones I have here. I mentioned the Argopilot, and I'm using the APM Revision 1, not the latest one that they have. And on the NATSA, I'm using the NATSA GPS controller. Depending on what level of automation you want to go with, you have different choices. So, the NATSA is much more limiting. It doesn't have that waypoint control like we talked about, whereas the Argopilot does. You can go with one that's called a Wukong M, which is by the same company that does NATSA, but the cost is ridiculously higher for it. So if you really want to do waypoints, and you should be pretty confident that you want to do it, but if you really want to do waypoints, then the Argopilot's probably the way to go. But you have to decide whether you just want it to augment reality or you really want it to fly a waypoint. And you also have to decide on open source versus commercial. So the Argopilot's fully open source. You get the firmware. You can modify it to your heart's content. The NATSA is a closed box. You're not touching it. You're very limited on what you can do. And they both have pluses and minuses. I'll tell you the NATSA works out of the box much, much better than the Argopilot does. But the Argopilot does work. It just takes a little bit of tuning and patience to get there. So a couple of some other considerations. The TX and the ARC setup. If you're familiar with RC devices, you probably know this already. The controller I have here, which is it's got kind of a dizzying number of controls. It's actually a 9-channel controller. I find 9 channels is really helpful for both of these devices. Although right now I typically use 7, but having 9 gives me a little bit of future capability. The least that you can have and actually fly one of these is around 4 channels. But this comes back to what you want to do with accessories as well. So for instance, with 9 channels, I have the ability to set the mode while it's in flight. So, if I only have 4 channels, I can't swap it to loiter mode while I'm in the air. With 5 channels, I can swap it to loiter mode and tell it just to stay still. Or I can flip it out of fail-safe, or I can do a number of different other options. I can also articulate the gimbal on the bottom. So let's say I want to point it at something that is at a different location. Well, I can use the controls on here to point the gimbal. I can turn lighting on the quadcopter on from the controller, and those things are nice. And to be honest with you, it's not that much more expensive to get a 7-channel, so I would recommend doing it, going with that one. And I'll talk about the different brands in just a moment. You've also got FM. If you did RC devices a long time ago, you probably have FM controllers. They're not so, most folks don't fly with them anymore. You've got 900 megahertz, which some people do, but it has a lot of interference. And then you've got 2.4 gigahertz and the spread spectrum ones. A lot of folks like that better. That's what this is. It works fairly well, and it keeps interference down. So if you're just getting into it, there's no reason not to go that way. But 900 megahertz will work if you need to. And then there are known brands versus Turnigy. So I showed you an example of this high-tech Aurora 9 RC controller. It's great because it's got this pretty screen on the bottom, and you can see very well what you're doing. You can tweak it. But it's closed source, so I don't have the ability to open it up, to tweak it, to tune it, to do a lot of things. I can customize it, but that's the extent of it. There's an RC controller made by a company in China called Hobby King, and it's $60. It's made by actually Turnigy, but it's just a rebranded. Turnigy's their homegrown brand. Anyway, it's $60. It's based off of an Arduino, so you can open it up, you can update the firmware, you can do anything you want. It's cheap and it's very capable. A couple of people have reported having to touch up the soldering, but it's very customizable. And if you're getting into it and you want to be infinitely flexible, or you want to do it cheaply, a lot of people have gone that way and been happy. Some fun accessories that you can add. One thing I didn't point out about this picture, which is interesting, is that you'll notice on top of the landing gear, I've got a nice USB cable wrapped around the landing gear, so that I can actually try and take off inside without having it go through my ceiling or hurt anybody. So it's fun to have a harness sometimes to test with. So if you watch the video down at the bottom, you'll get a pretty good perspective on what it can do. On from a height perspective. This is one of the latest tests with the gimbal. So this is actually in my backyard. You can see it actually taking up and going up a couple hundred feet in the air. It works well. It's fairly stable. I mean, realize up there the wind is 17 to 20 miles an hour, and it's holding it pretty well. You'll notice when I drop out of the sky, I just kind of cut the power and let it fall like a rock. But it gives a good example of what you can do there. Now, from a first-person view, if you want to do that, you've got to think about a couple of things. You can use stationary, like I talked about, where it's just mounting a camera. That works. There's no issue with doing that. You can use a gimbal, which you see on this one, and the gimbal allows you to stabilize the video. But probably the third option is the most fun. So the third option is one that I have for the airplane, but I don't have it here. It's called an FPV pod. So basically where the canopy is, the canopy actually comes off, and there's a pod that goes in its place. And the pod is effectively a camera mounted to 2 servos, and then you can actually articulate the camera while you're flying, which is really cool to be able to do. And then when you want to take that even a step further, so these are goggles that are used to fly. So if you're using it acrobatically, or you just want to see it when you fly, you can put these on, and it looks like you're flying a plane, like every video game you've ever played. But these also have head trackers built in. So you can do 2 things with the head trackers. You can make the head trackers actually feed what the plane is doing. So I can turn my head and make the plane turn and fly where I'm looking. Or probably the neater option is that I can program waypoints into that plane, tell it I want to fly this predetermined route over this farm or this neighborhood or whatever, and then use the goggles to look around as it's flying. If you saw what some of the Japanese folks did at Fukushima with their planes, they actually could look around with it, and they used something similar. More advanced than this, but this is pretty cool. It's really neat to be able to use the head tracking, and it's probably one of the neatest options. So some other ones, second, recorded versus transmitted. So for a long time, I didn't transmit video while it was flying. All I did was record the video, and then afterward I would download it, which works. I mean, most of the time, I can just capture the video that it flew. But I like having it transmitted, and being able to see what it's doing when it's doing it makes it much more viable. So if I want to fly through a set of trees or around a neighborhood or into somebody's backyard or anything like that, if I can't see what the quadcopter is seeing, I don't know what it's doing. But when I can actually see what it's doing, I have a lot more capabilities into what I can actually do. Not that you should fly it into somebody's backyard or any of those things, but that's a different issue. If you just want to record it, it's very easy. Transmit it gets a little more complicated. I use 5.8 gigahertz for the video, which works okay for me. Actually, I use 900 megahertz for the telemetry, 2.4 gigahertz for the RC control for the transmitter, and 5.8 gigahertz for the video. If I don't have that kind of difference, they start interfering with one another, and it causes problems. Camera controls, I mentioned before that I could literally control the FPV pod or the gimbal from the control. So that's another capability that you have if your controller or transmitter has enough channels. On-screen display is nice. So on both of these quads, I have on-screen displays, and what they'll actually do is report back to me GPS coordinates, altitude, speed, and a host of other factors, so I can see what it's actually doing. I can see if it's falling out of the sky. I can see the battery life that's left. I mean, let's be honest, when it's 300 feet away, I'm not going to hear a buzzer telling me that the battery's getting low, right? And it can fly back to me if I wanted to, but it's awful nice to be able to monitor how far it is before I get there. And the last one, I talked about the goggles a little bit. There are a number of different vendors that make the goggles. These are made by Fat Shark, but it adds a really nice capability. I will be honest, I still can't fly it just using the goggles. It doesn't make me nauseous. I just can't do it yet. One of these days I'll get there. All right, so there are some options for these concerning telemetry. So I talked about on-screen displays, and that's the first type of really basic telemetry. At the very least, what I want to know is if one of these crashes, what are the GPS coordinates so that I can go find it? Because I don't really want this laying somewhere and losing the amount that I've invested in it. I want to be able to go get it. So if it can tell me the last viable GPS coordinate that it was at, then that's what I would call simple telemetry. It gets that information back to me. Moderate would be real-time stats. What speed am I going? What altitude am I at? What are my GPS coordinates? That gives me a good feel for its health and what I can do with it. And then the last point is complex. So with the custom quad that I have here, I can actually put it in loiter mode, and then I can reprogram. I can reprogram the waypoints. So I can tell it, now I want it to go over my neighbor's house, or I want it to go over a barn, or I want it to do whatever. I can do all that without ever landing it. It can be 100 feet in the air, and I can redirect where it can go. And that I would call complex because it, it's not that difficult to do, but it requires a lot of setup to make work. And it's kind of nerve-wracking to, reprogram those GPS coordinates while you're flying it. So this one, you can see the video there. The video is very short, but you can see that I've got a lighting setup on the F450. Flying it at night is very difficult because when it flies in front of the trees, I can't see where it is. I can't see what it's doing. It's very difficult to do anything with. So this one actually has 4 lights on it, and it will have 2 more landing gear lights when I get around to adding them. The things to think about from a lighting perspective, do you just want it to be running lights? In other words, I just want to know where it is in the sky and be able to track it down. That's easy. You can get, hook up some LEDs to it, and you got no problem doing that. If you want to get more complicated, you can do programmable. So, for example, with this quad, the F450, what it actually does is when I get up in the air, it blinks. And you could see it slow blinking there. But when it gets higher, it changes the blinking structure. When it gets within 10 feet of the ground, it illuminates the landing gears so I can see what's under it when it's coming down. I've got lots of flexibility, and I can even control the lighting from the RC device. So, and then cost is one of the last things. I put this up there because when I told you that my first quad that I built was a printed frame with aluminum that I bought at Home Depot, that's it. So, I mean, literally, it was $2 worth of aluminum round from Home Depot, the printed parts, and actually used a landing gear that I had. And it was very cheap to put together. And you can enter it very cheap like that, or you can go expensive and get some of the other options. But to lay out, the kind of cost that you're talking about, and when you're building one, if you're actually interested, and I hope everybody can see the numbers. I'm not sure if you can, but this is just these are rough numbers. But just to give you an idea, the transmitter that you're looking at right there is about $400. Now you can get a $60 one like the Turnigy, and if you've already flown an RC device, you may already have the stuff, so you don't have to worry about it. The receiver, if you're buying a new transmitter, it typically comes with one, but otherwise you got to buy one, and that for a 9-channel is about $100. The airframe, if you do it yourself, I put about $100 because that's about what I have into the custom quad there. The Natsa frame you can get for about $30, so it's pretty cheap. The motors, it depends. I've got some cheap Chinese motors on the quad, on the custom quad, so it was $72. The DJI ones are a little more expensive at $96. You use an ESC on multi-rotors, and basically that stands for electronic speed control. It handles how fast those propellers are spinning, and so it all depends on which one you got. The Natsa ones are a little more expensive, or the DJI ones are more expensive. The Turnigy ones are cheaper. Depends on how you want to go. From a brain perspective, the Arja Pilot is about $200. The Natsa controller with GPS is about $450, and you can also see up there I put the Wukong M that I had spoken about. That one's about $1,200. Again, a lot more capabilities, but it also jacks up the price quite a bit. You've got to have batteries and a charger. The batteries are cheap from China. There's almost no reason not to get those. The charger is about $30. If you've got RC stuff, you probably already have the charger, so you can reuse it. But, I would say at that level and up, that's really your entry point. That's what you're looking at. So you can get into it pretty cheap. If you've already done RC stuff, you could probably build one for, $400, $300. If you don't, it's going to, jack up the price a little bit, and you just need to decide how much you want to spend on it because you've got lots of choices. Excuse me. As you get down to the other options like telemetry, they add a bit to the cost. Telemetry, open source. The open source solution uses 2 XPs to communicate back and forth, so it's pretty open what they can do. I use the XP Pro 900 megahertz, so they work up to a mile, so I've got lots of room, and it was $86 from DigiKey. The Wukong M is more expensive at $260. That gets kind of pricey. Then if you want to record video, I put $200 because that's about what a GoPro costs. If you want to transmit it, it's another $80 or so for the transmitter and the RC and the receiver. And then the on-screen display, on the Argent Pilot, it's about $50. That's the one I have on it. It works just fine. Again, because it's open source, it's a little easier to interface and to get all of those pieces of information where I can't get that with the commercial one. But the commercial one for the Wukong M is about, for the knots in the Wukong M, you typically buy a whole solution. So these have like an Eagle Tree OSD, and it gives you all the information. And then, programmable waypoints if you want to go that way, and then you can see the totals at the bottom. So that's really, that's what I had from the presentation that I wanted to go over. I don't know how we relate to the time. I probably made up a little bit of time, but I wanted to give some time for people to come up and look at these and ask any questions that they might have. If we can do that now, I think that would be ideal. Do we have any questions for me for the crowd before y'all come up and see? That's a good question. I have no idea. At this point, I built them. I have them. Nobody's contacted me to say I can't fly them. So until they do, I'm not going to sweat it much.
We've got a park in Hendersonville. It's got a remote control airstrip. It's got a big sign right there. You have to have a permit from an RC club. You have to have some kind of training, some kind of authorization before you can come in there and fly.
Well, these. Well, I'll be honest. I fly these. There's a park. I'm from Memphis. There's a park in Memphis called Shelby Farms. I go to the park and I fly it at the park. It's not an RC field. I go in my backyard. You saw the video there. I fly it in my backyard. I've never had anybody come out and tell me I can't do it in any of those places. And when they do, I'll deal with it. But I know there are a lot of RC-specific parks that you can go to. And, if you're a member of a club, that's definitely an option. But, I don't have any fear about flying it in a park. And I'll do that until, somebody tells me not to. I've considered putting an FLIR camera on it. I want an FLIR on the SkySurfer and on the F450. I've got some specific uses for it that I think would be very interesting. But unfortunately, the FLIR cameras start at about $4,500. So it's a pretty pricey proposition. And I would want to make sure that I could fly it without even thinking about crashing before I put a $5,000 camera on it. Size, weight, capability. Actually, the best, or maybe not the best, but the easiest FLIR you can find on one of the Cadillac sedans. They had an FLIR camera embedded in the bumper, and that FLIR camera is very good for quads. And if you can find one that you can, like in a junkyard or somebody trying to get rid of the parts, then it's great to use. But a lot of junkyards have realize how much people will pay for those, and they've jacked up the prices a good bit. So that's probably the easiest and cheapest route. Otherwise, you're going to look at like the TAO camera, like a TAO 320 or one of those. There's actually a guy in, I think it's in Texas. He's got some videos up on YouTube. His YouTube, I think it's, he calls his plane the Hog Flyer or the Hog Flyer or something like that, and he actually hunts pigs. By flying the quad, or by flying his quad or his plane, and finding where the animals are. I think you could do that hunting, and people would be pretty interested in it. But anyway, that's what I think about infrared. I think it's definitely viable. It's just pricey. Any other questions? All right. Well then. we'll adjourn. I'll give folks a few minutes to come up and see and ask any questions, and we can go from there.